If we head back to the 1990s, there was an American animated series, Courage, the Cowardly Dog. The series became quite popular among the people. That show was a perfect blend of horror and comedy, wasn't it? In the middle of nowhere, next to their cottage was a very tall fan-like structure. Do you know what that gigantic fan is called? A wind turbine. Our teacher of grade 5 told us that this wind turbine generates electricity. Growing up, my biggest curiosity was how this wind turbine generates electricity. Yes, these tall and enormous fans generate electricity. Today, in this video, we are going to talk about what this wind turbine is and how it works. Without further ado, let's jump into the working demonstration of a wind turbine. To understand the concept, we first need to comprehend what a wind turbine is and how it is made. Ever since man has started pondering on the unit of life, he has been using natural resources to create a better facility for himself. The wind is what we are surrounded by. When air moves due to the difference in the temperature, we simply name this moving air as wind. A normal person might see wind as something to enjoy, but the eye of a mechanical engineer sees the wind differently. For a mechanical engineer, wind brings countless opportunities to provide with new facilities and make existing facilities better. From flying a kite in an unmeasurable sky to sailing in limitless seas, man has been taking advantage of the wind. But generating electricity using wind energy is a clever yet sensational idea. A wind turbine is a set of apparatus that converts kinetic energy into electrical energy. In simple words, we can say that it is a unit that uses the kinetic energy of wind to generate electrical energy for our utility. The structure of a wind turbine is a fascinating one, and to be honest, it looks pretty decent. Basically, 5 main elements contribute to form a well-functioned wind turbine. However, other supplementary parts are also attached to it. Let us talk about what each part is composed of and why it is present in a wind turbine. Number 1. A tower. A tower is one of the most prominent parts of a wind turbine, as it holds a complete wind turbine together. Or in simple words, we can say that a tower supports the whole structure of a wind turbine. Now that we know that it provides support, we can anticipate that it should be composed of some sort of strong material. Maintaining stability is very important. It is either made of steel lattice, similar to the structure of transmission towers, or it is composed of tubular steel or concrete. Wood is another candidate that is under consideration for the material of the tower. A tower is definitely a major part of a wind turbine, as it contributes to almost 30 to 65% of the total weight of a wind turbine. As of height, the taller a wind turbine is, the better output it will provide. But you will ask why a taller wind turbine works better. It is due to wind shear or wind gradient. As we know, up there, on the higher altitudes, the velocity of wind increases. Hence, what tall towers do is to make it easy for a turbine to apprehend more wind energy in order to make more electricity. So that is why towers are usually 260 to 380 feet high, to achieve more efficiency in converting wind energy to electrical energy. Number 2. The rotor and its blades. The second most important part of a wind turbine is the rotor and rotor blades. What a rotor might be? As indicated by the name, a rotor is a rotating part of the wind turbine attached to the top of the tower. Along with the rotor are its 3 blades and the hub. The hub is the part of the rotator to which 3 blades are attached. It is similar to the central point of a wheel or a fidget spinner. Now comes the blade of the rotor. A rotor does not always have 3 blades. It can have 2, 3 or 4, depending upon the type, but in aerodynamic, 3-bladed wind turbines work the best. The blades are somehow similar to the wing of an airplane. They are hollow in the middle and are light in weight. The trend is to keep the inertia as high as possible to generate more electrical energy. Therefore, blades are kept light in weight and long in length. The idea of low-weight blades is to reduce the gravitational forces, but the lightweight blades does not mean that it will be of low quality. The quality of the material is selected very carefully, as it has to survive harsh conditions like lightning strikes and temperature gradients as well. Blades are either made of reinforced carbon fiber plastics or fiberglass. When the wind moves over these blades, they move and rotate the rotor, which then drives the generator to produce electricity. Number 3. A nacelle. The nacelle is like a substructure that sits on the top of the tower. It is an electric enclosure, a sort of cabinet that contains a gearbox and a generator. It retains all the vital machinery to drive a turbine. Controller, brake, and low and high-speed shafts also reside within the nacelle. The nacelle is attached to the tower through bearings, which help it to rotate according to the direction of the wind. The high-speed shaft tends to drive the generator of the wind turbine. When the blades of the turbine rotate, they spin the speed shaft that is attached to the generator through the gearbox. The gearbox increases the efficiency of output by increasing the rotational speed from low to high. It massively increases the motion of the rotor from 18 to 50 revolutions per minute to round about 1500 to 1800 revolutions per minute. The function of the controller is to protect the turbines from any type of damage. If turbines operate about the wind speed of 55 miles per hour, they are more vulnerable to damage and scarring. Therefore, if the controller senses the wind speed above 55 miles per hour, it automatically shuts off the turbine machine. Number 4. A generator. Probably the most important part of a wind turbine is its generator. The generator works on the basic principle of converting the mechanical energy of wind to electrical energy. The profile of a generator is similar to that of an electric motor. A generator produces an alternating current of 60 cycles per second. It is usually a synchronous or induction generator. Number 5. Foundation. Last but not the least, we have a foundation. The foundation is like an enormous block of concrete that lies under the ground and is covered by soil. The foundation holds the whole structure of the wind turbine. However, for an offshore wind turbine, the foundation is located in the water and supports the mass of the turbine. Now that we know what each component of a wind turbine controls, we are going to see how a wind turbine generates electricity. But before that, if you are enjoying this video, don't forget to subscribe to our channel and press the like button. It helps us with the YouTube algorithm. Now, let's continue. The principle on which a wind turbine works is fairly simple. Think of it this way. Why do we have electrical appliances like fans and air conditioners in our home? We use them to survive the heat. Fans and air conditioners use electricity to generate wind. But a wind turbine works in the opposite way. A wind turbine uses the energy of wind to produce electricity. Wind varies greatly across the United States and other continents of the world. Finding a perfect spot for wind turbines is highly crucial. Wind drop or blowing too hard of the wind both can damage a wind turbine. So keeping in view all the conditions like landscape, pressure gradient, and friction, a perfect spot is predicted for setting up a wind farm. As the wind moves, it rotates the blades of the turbine. The blade rotates at about 3 to 5 meters per second, which is fairly low. This whirling of blades turns the high-speed shaft inside the nacelle. This action stimulates the generator. The generator inside the nacelle then starts to produce electrical energy from this kinetic energy of the wind. This electrical energy is then moved through a transformer, which neutralizes the voltage. Then this electricity is distributed to the local community or national grid. Electricity can be generated from the sun, water, or biomass, etc. But we prefer wind energy because it is fairly cheap. We are depleting water resources on Earth, so we can't even think of wasting water on electricity. The sun does not shine equally on all equators. Biomass requires a lot of time, so wind is the easiest way to generate electricity, and it is environmentally friendly also. The electricity produced by a wind turbine is affordable, pollution-free, sustainable, and clean. This brings us to the end of the video. Let us know in the comments section below what in your opinion is the future of wind turbines. Make sure to subscribe to the channel and share this video with your friends. See you in the next one.